Perfect. Okay, good. Hello, everyone. Good afternoon. I hope you feel fine. I will present a research project from my university. I'm from Germany, from the southern part, and the university is in Bamberg. That's a city in Bavaria, and maybe you know this city, Bamberg. Maybe who of you has heard about this city, Bamberg, before? Oh, that's awesome. Oh, okay, perfect. Okay, good. Well, actually, it's quite famous, so I did not expect that you know it here a lot, but it's quite famous for the good beer, because there's the highest density of breweries in all over the world. So, unfortunately, I've been here in Moscow already like 4 days, and I had some beer as well. And I cannot advertise the German beer a lot right now, because you have very good beer here as well. But please don't tell anyone from friends and from home. Okay, next to my student life at university, I am a member of the Hypriot team. That's an open source project. We aim at bringing Docker, container virtualization, to the ARM CPU architecture. Every one of you has an ARM in your pocket. There's almost no smartphone that is not running on ARM. Like, it's a very lightweight, very small CPU, and very useful for small scenarios. And what we are doing is we make porting, like using Docker on small devices like the Raspberry Pi, an out-of-the-box experience. Like, you just download our image. We have an operating system. You flash it on an SD card, put it into a Raspberry Pi, like one of these ones here, boot it up, the Pi, and it works out of the box. You can use Docker, Docker PS, and all the Docker tools right away. And so my talk very much is like a joint project of a nice research about the Internet of Things, small-scale computing, and the stuff that we produce at Hypriot. I also have some bad news for you. This is a scientific project, and science for some people is boring. And I think that's true, because my slides are not that colorful. There's a lot of text in there. So it might be a bit boring, but on the other hand, I think the quality is maybe even better. I hope you approve that after the talk. And to compensate for the slides being a little bit boring, I prepared a live demonstration. So we will have some fun with the cluster during the talk, and I hope you like this compensation for the scientific boring slides. What's behind the title? The title is basically about, I put 2 different types of orchestration software on these Raspberry Pis and test which one is better, Kubernetes and Docker Swarm. So, let's see. That's the content. But it's self-explaining, so I just go through it. You see it on the right side, the index during the slides. So the motivation, why should actually someone do this? Well, people observe a paradigm shift from thinking in big data centers to a smaller scale in size and power of computing. So the architecture size things, the energy efficiency increases, and devices get more and more cheaper, more available for also scenarios where the budget is quite low. And then this is basically the foundation for the IoT, the Internet of Things, that has been defined in the meaning that we know today in 1991 already. But in the last years, it gets more and more attention, and I expect that this attention will grow much more in the future. Also, what motivated me to do this is it's a bare metal thing that you can use at university, and for everyone who wants to learn about cloud computing, you can touch it. It's physical. You can really touch what you're doing, and it's not somewhere running in the cloud. Also, you can use it for interesting scenarios like distributed systems, microservices, SOA, services-oriented architecture. And also, it's very popular. There are so many people playing with it. There are so many interesting projects. You may know some of them. They are really exciting. And the Raspberry Pi, we use it because it's the most popular single-board computer available, according to surveys from the Linux Foundation, for instance, by far. And also, of course, at Hypriot, we contributed a lot to make Docker running on ARM possible. So, of course, I play a lot with that stuff and like to use it. But why Docker and Kubernetes? I could use some other software as well, right? There are many available. Basically, I chose Docker because Docker is available for ARM for not that much time. And it's very useful technology because it's very lightweight. You cannot use virtual machines on these small devices. You need to have something more lightweight. And also, since this release mentioned in August, it ships high availability features. So you can actually use it for building your own small data center, and that's awesome. Kubernetes, on the other side, is available for a longer time, but it also, the support for ARM has just been extended. It had been available for quite some time, but it did not work very much, and to be honest, it doesn't work very well today as well. But the support grows, and the maintainer who's working on that is pushing it very hard to make it available for ARM. Also, it's known to be very reliable, so it's a big hero in the world of high availability orchestration software. So I think it's interesting to have a look at it. And also, it's not that resource intensive. So it's actually not that lightweight than Docker, but still, it's possible to run it on these small devices. What about others? There's much more, but they are either not compatible to ARM, to resource intensive, or to resource intense, and not for general purpose. Some of them are for very specific scientific scenarios. Some of them, yeah, you only can run with one software. So this is why I chose to have a look at Docker and Kubernetes. Some of them are not even like in experimental state, like in very early experimental state. So I expect more of them to come soon, but for now, I think this is the best choice for such a project. When you start a scientific project, you wanna investigate. Maybe there are some other people working on that to collaborate instead of work separately on these topics. So I had a look, and the first evidence that someone worked on that small scale with this kind of orchestration software was 2012. The University of Glasgow published a project where they played around with the Raspberry Pis. At that time, Docker was not available. The state of the art was LXC, which is, or was at least, the main Linux container virtualization software for Linux. Now Docker is kind of pushing it away. The largest project at that time was a 300 Raspberry Pi big cluster, which is a lot. And then some years later, in 2015, there was a turning point, which was that Lukas Källström and the University of Glasgow had a look at Kubernetes, and they tried to port it to ARM. The bad thing was both worked on that project independently. They didn't join their forces, but after some while, they talked to each other. The University of Glasgow stopped working on it, and Lukas Källström went on. He implemented a lot of features, and in the end, he got the maintainer of Kubernetes for ARM, which he is also right now, and is a very interesting person to talk to if you're doing this stuff. And then finally, this year in June, two guys from Denmark, Kasper Nissen and Martin Jensen, they wrote a brilliant master thesis about cloud computing at small scale. They were able to put Kubernetes on this small cluster and run some tests on that. And this is something that no one had ever done before. People were like sometimes figuring out how to get it up and running, but they did not test it. They did not put high load on that cluster. So that's the first evidence that actually someone digs deeper into that topic. And what I do on top of this is I take Docker, put it next to it, and compare these two software tools, and put a little bit more of tests on top. Yeah, how did I start? This is the hardware that I use for it. It's from Pico Cluster. They sponsored this to talk about it, to have talks about it, and to play with it. So that's free for everyone to buy. Not free, but it's just available as a kit. You can just plug everything together, assemble it, and then use it. And then the software comes. With this kit from Pico Cluster, the hardware is basically set. So software-wise, this is a very elaborate step because good experiments are not easy to set up, to define. And of course, I wanted to do a good experiment, so we had to think about all these criteria for good experiments, like choosing software by not being influenced by Hypriot, for instance. So instead of using Hypriot OS, I also look at other operating systems to use. And then when it comes to setting everything up, you need to, think about more than I at least thought at the beginning. For instance, all SD cards should be of the same type. The network switch should really work. You should test it up front. You should isolate the network, not that any other devices in the network are broadcasting packages and interfere your data and your packets. Then, and just some examples. Software-wise, that's a little bit more. Of course, the question, which OS do you use? There, I would say these three available, Raspbian, Arch Linux, and Hypriot OS. Actually, for Docker, only Hypriot OS works very well. For Arch Linux, it doesn't work, and for Raspbian, you have to set up a lot of stuff up front. It works after a while, but I kind of had to choose Hypriot OS. The flashing, I did not count how often I flashed these SD cards. I stopped counting. But you have to at least try to automate it, to use scripts for this, and to configure the devices. Again, the network, I try to have 2 SSH servers running to, when I run a test by crashing a node, to have still a connection over the Wi-Fi, because there's each Raspberry Pi has a Wi-Fi connection and an Ethernet plug to connect to. Of course, update software, monitoring tool that is able to monitor everything you need. There are many available. Some are not able to run on ARM and so on, so this is also an interesting topic. Configure your desktop machine such that also this one has no software on it that destroys your network by filling it up with broadcast messages. Some things like time server, that's all boring stuff that you need to think about, but you don't really like to. Also swap space. Kubernetes takes some amount of memory, which we will see later, so you might need to think about swap. Yeah, and of course the most important thing, automate, automate, automate. A lot of things I did several times, several times, so it's very handy if you automate things. Like scripts, basically bash scripts that you execute. Just some of the things you should think about when you're doing these experiments. So next, going to the side of Docker first. The setup was very easy because it comes with Hypriot OS out of the box. You can just download it, flash it, boot it up, and it works. So that was easy. Kubernetes was a little bit more elaborate because, you have to configure and run some scripts. And the software to make this running comes not from Google itself, but from the maintainer, Lucas Kellström, who has also like a side project running on that. So you have to use that one, which is fine, but it's really bleeding edge. And the setup process is not at all like deterministic. You can expect failures, you can expect that you have to hack a little bit and to do workarounds. I brought one of the workarounds with you. This is basically the setup command like after the last pipe that you had to run, but it was an interactive shell. So I wanted to automate it. The thing is, well, this command basically automates it, but the thing is that the parameters were not always asked in this order. And if this setup command does not run exactly as it should be, the operating system and all the setup is killed. So we had to reflash the whole SD card. So there was also some interesting things that I ran into. Luckily today, just some weeks ago, this process is not necessary anymore. Now it's very easy to set up Kubernetes with just 2 commands, as it is the case with Docker. So here you have the 2 software stacks. You have, on the one hand, Kubernetes, on the other hand, Docker Swarm. And it's, I think, well comparable, because there's everything similar except Docker and Kubernetes. You have to know that Kubernetes uses Docker as a base. So this is why on the level of Kubernetes, on the right side you don't see anything, because both have Docker. Kubernetes is, so to say, just an extension for this stack on top of Docker. So the testing scenarios that I ran on this cluster after everything was set up. The first one was resource usage. I think this is important for when talking about high availability, because if the software takes too much resources, it influences the availability. So I also measured some resource consumptions. And then I did a load test, fired many packets on this cluster, and figured out at how many requests per second it breaks down. And the resilience test. By resilience and high availability, for me, is exchangeable. I prefer the resilience, because resilience from old Latin means, directly translated, jumping back. So jumping back to the previous state, recovering to the previous state, which is something that is more expressiveness than more self-explaining, I guess, than high availability. Okay, then I run these tests, and I started with the first one, which was by far the easiest one, and see the results, which are, I think, very interesting to see how lightweight Docker really is. In the first scenario, you have the CPU usage in percent, memory usage in percent, the process of Docker and its CPU usage, just of the process itself, and then from Docker again, the memory that is only needed by the Docker daemon. I excuse a little bit for the abbreviations, but the space was not very much on that slide, too much numbers. So in the first scenario, you see that Docker is very lightweight. You don't see that the Raspberry Pi is stressed at all. In the second scenario, it changed a little bit. If you see 2 numbers, the first number is the one for the master, and the second one is the one for the worker. So it's not a big of a difference, but with the memory usage of about, let's say, 7–8%, this is something that Raspberry Pi can handle quite fine. When it comes to Kubernetes, which is the third scenario, then it's getting interesting, because Kubernetes puts a lot of add-ons on top. It's not just an orchestration manager. It offers a lot of capabilities inside that you cannot, at least not all of them, you cannot all of them disable. So it puts up a lot of additional things. Like, for instance, a nice graphical interface, which is not included into Docker, but it's built into Kubernetes. So most interesting, in the third line, you see on the last column that half of the memory that is available in a Raspberry Pi, which is 1 GB, is used by a Docker master. That's fine so far, but it's still, when there's a lot of traffic on that cluster, it might increase a lot, and then you have to think about it. But for simple test, that's fine, and the worker is with 160 megabytes of memory, fine as well. The other data are very much in the green area, I would say. What's also interesting is Kubernetes runs a lot of processes. starts a lot of processes just for the basic setup. And you see that on the very last sentence on that slide, that when you run Docker, there's only, I think, one process children. Kubernetes offers 41. That's much more. And then came the Big Bang. The Big Bang was that Docker and Kubernetes did not handle the other tests. That was for me very surprising because I expected that an orchestration manager is able to handle a cluster as an orchestration manager, like handling incoming requests, forwarding them to the nodes, and so on. But in the next test, when I wanted to try exactly this, it did not work. So it was even more depressing that there were more things going wrong. For instance, there were kernel panics, and systemd reported that the daemons were crashing down. I had to reconfigure them and restart them quite often. Also, there were a lot of problems in the network stack. The mesh routing that makes sure that incoming requests are going to the right container on the right node. And when a node crashes, the routes are updated such that new requests are pointed to the containers on the other node instead of the broken one. And this does not work, or did not work at least, when I did this project. I found a nice site from a company called Bugsnag, who stated exactly this. The intelligent routing was very spotty, sometimes hanging during our requests, and sometimes not even accepting inbound connections at all. So I was not the only one who experienced that, which made me a little bit more happier. But how to go on? And because at that point, basically, both tools did not work to the minimal extent for my tests. I cannot do load tests when I get timeouts. So what was my plan B? Before I talk about the plan B, I give you a screenshot of how this looked like. The correct answer from the web service of the cluster is the one beginning with IAM, and then it shows the ID of the container where the web service runs in. And just in the middle, you get timeouts. Not good. And also, what's interesting, my monitoring tool reported that the inbound traffic was not balanced across the nodes. They were unbalanced. They showed some randomness in their distribution. The top graph in this slide should show the balanced distribution, but yeah, I had more often the picture on the bottom. I had a look at GitHub, where the Docker game plays, and some other people reported this. And as you see on the right side, you see milestone 112.2. This issue is closed. So this was for me, after some days of doing some research, I hope that maybe it works with 112.2. And I was right. So the mesh routing in Docker was fixed, and Docker worked out. Fine so far. What about Kubernetes? Nope. Kubernetes did not work, so I had to have a plan B. My plan B, it's not that easy because I put a lot of effort in defining all the tests and all the setup, and then suddenly I had to throw away my plans because I had to figure out a workaround. And also I talked to, of course, the guys who wrote blog posts that made it running. They are not very many available. I would say worldwide about 10 people, and 2 of them are writing about it. And when I ask them, they often say, I don't remember, it was so complex, I cannot tell you the details. So it's still not reliable, it's still a lot of work, and I gave my best, but it was really hard. So what did I do? I mentioned the master thesis of Nissen and Jensen, and they made it running. They couldn't tell me how they did it, but they made it running. So, and I had similar tests. They had also like similar tests to the one that I wanted to execute. So what I did, I came up with this new technology stack. I basically take their data, their tests, and try to set them up in a similar way with Docker. Because for me, Docker worked, for them, Kubernetes worked. I wanted to compare it. Of course, this is now not scientific anymore, and of course, the comparison is lacking some foundation, because as you see, the technologies are very different. You have a different operating system, you have different versions of Docker, and so, yeah, it was not a good time, but at least I could run my tests. And this is what I did in the following. The next test was the load test. So I fired requests to the cluster. You see on the x-axis the number of requests per second, and the latency on the y-axis. And you see at how many requests the cluster broke down. And this was, and this has been run for different scenarios. The first one was having only one container with one web service running. Second one with 5, and then with 10. And you see that at about 800, 900 requests per second, there's the cluster breaks down when it gets this amount of incoming requests. If you increase the number of replicas, it almost doubles its capacity, but then it stops. If you increase it after 5 or 10 replicas, it doesn't have much more effect, which was also interesting to see. What about Docker? I excused the different style of the diagram because I used another software. So this is my own test that I run, and you see that the breaking point is earlier, where Kubernetes was at 800, 900. If you only have one container, Docker stops at 600. And also, if you have more replicas going on, then the breaking point is also earlier. In a summary, here you see it again, you see that basically Kubernetes is about 400 in average requests per second faster, more capacity than Docker Swarm mode. That was interesting, but for me, I'm not really sure if I can say that this is really a good comparison because the technology stacks are different. It was just interesting to still run my tests. Finally, the resilience tests. The resilience tests were all about can the cluster recover in case something breaks? Someone told me in the opening ceremony yesterday morning, Oleg Bunin mentioned that this is a very interesting topic, even more interesting than just putting load on a cluster. So I didn't understand that during the ceremony, but I was told afterwards. So here you are. You have, in this test, you have one replica, and you see when the blue line is going down that the requests are getting timeouts, or resulting in timeouts. And when the blue line is getting up again, the service restarted on another node, and this is like the gap that it takes for Kubernetes to restart a service on another node when the first node has been crashed. It was 47 seconds that it takes Kubernetes to get the service up and running again. Interesting, for Docker Swarm mode, it's much more, at 72 seconds. But again, different operating systems, different technology stack. The next one was, how does it change when you increase the replicas? And as expected, it changes a lot. The timeouts are only some tiny timeouts. As you will see, not very many, and you only have these 3 little peaks that are going down and showing timeouts, but everything else is working fine. This is again the Kubernetes test, and this is, okay, I did not put the graph for the Docker test, instead I have the numbers here. And you see that there's still a difference between these two, but not that much. Docker, when you have one replica, is there you have a bigger difference because it takes much more time for Docker to restart a node on another cluster. But if you have 2 or more replicas, the differences are diminishing. As promised, I would like to give you a live demo. It's called Let's Crash the Cluster. I have good news and bad news. The bad news are the live demo works, but when you plug off the power cable from a running system at some point it crashes and does not boot up anymore. And this happened like 1 hour ago. And I did not dare to reflash once again these SD cards. So luckily, and that's the good news, 2 nodes are still working. So I will show like half of the demo, or like the half of, with half of the nodes of the demo. For technical reasons, I will go upstairs and play the big brother, because we had to figure out we had to wire the cable upstairs. So because of that, I need an assistant that helps me to plug off the power cable of that cluster while I'm upstairs and tell you something what's going on and do some live coding on the cluster. Who of you would like to help me and crash my cluster? Not everyone at once. Thank you. Right now, please come to me. What's your name? Vladimir. Vladimir, nice to meet you.
Nice to meet you.
Applause to Vladimir for assistant.
No problem.
So
I
yeah,
used to recover things,
but not crashing it.
Resist the crash, yeah.
Okay. See here, you have 3 nodes.
Yep.
And when I ask you to crash it,
Yep.
please unplug from the first node the power plug. Okay. It's a little bit. You need some power to do this, but I heard.
I have it at home, so.
Oh, perfect.
I know how
Okay.
to plug it.
It's a little bit, but we figure it
Do I
out.
crash all the 5 or just one at a time?
Only one, because I only have 2 nodes working. So you
So I'll crash only the first one. That's it.
crash only the first one.
All right.
Okay. Good. All right. So, these are the 2 SSH connections to the cluster. If you want to have a look at the state of the cluster, you see that 2 nodes are available in the cluster, these ones. And we are now having a look at a browser who shows services that are running inside the cluster. This is one of them. This is the visualizer that shows 2 nodes. As you see, I had 4 nodes. The node 2 and 4 crashed, so there are 2 nodes left. And when Vladimir cuts off the cable, which please not now, but soon, then 1 node should disappear. And also, on this cluster, I hope it works. No. It should run a website. Of course, it should not, because there's no container running. Okay. So what I will do right now, I will start a container, a web service that has a website, just a website, on that cluster. So let's do this. The service is already initiated and defined, so I only have to say I want to scale the service, let's say 5 nodes. And you already see here that the nodes, the containers are started and are been running. And now the website should be available. Here it is. So, what I also can do is I can move these containers around. For instance, you've seen in the Kubernetes performance test that the master takes a lot of containers, a lot of memory. So what we can do here as well, you can move all containers from the master to the worker. But we now want to just crash the cluster. So Vladimir, I ask you to crash the cluster. Thank you. All right. We should soon see that there should be changes in the visualizer. Vladimir, could you please also plug it in again? Yeah, because it takes some time to boot up. Okay. What's now interesting, you've seen that the containers were distributed over the two nodes. So if I refresh the website, if the mesh routing would not work, we would have timeouts. But since Docker recognized that one node is down, it updated the routing tables, and we don't get timeouts anymore, or not timeouts at all. So if I refresh this website, it will always be running. As I mentioned, when I had the network issues, this was not the case. I often had timeouts. Let's see if there's some update here. It might take some time for this visualizer to update. In the meantime, let's have a look at this service. It seems like the demo gods are not having the best day with me. Okay. This is not the best sign, because this is the node that Vladimir crashed, and this node has problems with the Raft protocol, which cares about the cluster, like electing the master and the worker. Here you see all the containers running. But it seems like that the Raft protocol crashed. This should not be the case, but as I mentioned, this cluster has been crashed quite often times to prepare for this talk. So, yeah. I would say we leave it as it is, and yeah, I come back down again. Okay, you can switch. So, Vladimir, thank you, but it was not your fault. If you want to see this really working, because with a fresh Hypriot or with a fresh setup, it works. We have on our website, we have a screencast on that, where you can just see it, working. And this is also with 5 nodes, so a bit bigger. Okay. Finally, what are the next steps to do in such a project? I think it's interesting to not have just the services, but also the data. And the data is something that I think is interesting to look at, to have a look at Ceph, cluster.fs, to see how the data is moving around and made highly available in such a cluster, and how to look at it, how much performance, how much the performance changes if there are changes in the cluster state. Also, it would be interesting to have small devices that are a little bit more powerful in terms of network. Raspberry Pi has a bottleneck in network I/O because it's connected only via the USB interface, not directly on the main controller. So this is a bottleneck. Might be interesting to have a look at this. I will publish a paper about this project and all the details with all the links to interesting websites that I had a look at, and got more information about it soon on our blog post. So if you are interested, have a look. And also, you see my Twitter handle, also soon at the last slide. Have a look there. There we publish at Hypriot and myself more updates about this. And I would love you to talk to you there. The lessons learned, the animation was a little bit mixed, okay. The biggest thing I learned in this research project was don't trust, measure. As you saw, obviously you cannot expect that a software that should be able to manage a cluster can actually manage a cluster. It might be because it's experimental, bleeding edge, and not officially supported and so on, but just don't trust the release notes and test it on your own. Not sure if I mentioned, but just don't measure. Don't trust, measure. So this is really something that I was very surprised to run the tests and not being able to make it up and running. Once more, such that you know. And finally, I hope you enjoyed the talk. And if you have any questions, that would be the best time to do that now. Thank you.
Ни у кого нет вопросов?
Does anybody have questions?
I think I'm getting a translation here.
Vielen Dank erstmal. Do you see a practical
in German, okay.
use case for this? I mean, we can play around at home and so on, take a cluster with Raspberries, but practical use case?
Like a useful use case. I mean, this is the basic infrastructure for instance, smart home appliances. In a smart home, you have to have higher availability because you don't want that you come home and your main door is not opened automatically by some sensors. And if a node is crashing in the smart home network, you want to have this. You want to have it in a state that is always available. So this is the basic infrastructure. Of course, you cannot use this as it is, but it's the basic infrastructure to build, for instance, smart homes. And also, I think many infrastructures that include sensor networks, because they all should have highly available resources to run services, to connect sensors, and to make sure that if something crashes, the overall system still works. Like business critical scenarios in logistics, for instance. I think there are many scenarios out there. Sure.
Еще вопросы?
Any other questions?
I have a question. Which of the two systems did you prefer from the personal point?
Could you speak up a little bit more in the microphone, please? Okay.
All right. I'll repeat it. Which of two systems did you prefer more, Swarm or Kubernetes? Just like the ease of use, your personal preferences, whatever input. Thanks.
We worked a lot with Docker, so I'm a little bit biased, but from an objective point of view, I would say Docker is the more easier to use tool. It's more straightforward to define services in the cluster. With Kubernetes, you often have to have file like descriptions. You have to write file descriptions for services, and often cannot just execute commands. This is it's possible, and you have a lot more possibilities doing this. We can deploy more complex scenarios with Kubernetes. But for simple, so it depends. For simple infrastructures, I would prefer Docker. If you want to be a little bit more complex, then I would go for Kubernetes because the feature set of Docker is still very basic.
Если нет вопросов больше, давайте еще раз.
If we have no other questions, let's thank the speaker for this outstanding speech.